Hey everybody, today's video will be looking at problem 55, jump game. You are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or false otherwise. So example 1, we see 2, 3, 1, 1, 4. And actually let's visualize this a little more clearly over here. So the first one, 2, 3, 1, 1, 4. What's happening? So 2, it can jump 2. So we go all the way to 2. Then 1 can jump 1. This new one can jump by 1 until we've reached the end. Example 2. Three can jump by 3. And this 0 doesn't help us because we can't move at all. So we try 1. 1 tries jumping by 1, hits 0. Now we try 2. 2 jumps by 2 and hits 0. So that's why we can't make it to the end. So I think the two interesting properties that we see from this, very basic exercise is that one, we're repeating the same kind of approach each time, where we want to go as far as we can, and as long as we can keep moving, we do keep moving. In this case, we jump as far as we can, but otherwise we backtrack, but then still try to jump as far as we physically can. So those two properties, one of doing the same process over and over again, and two, being sort of greedy in that we are moving as far ahead as we possibly can with each move. Like, those two properties indicate that this is a dynamic programming problem. And so the solution for this won't necessarily involve using top-down or bottom-up solution, but those two elements of repeating sub-problems and taking a greedy approach are emblematic of a dynamic programming solution. So definitely a good stepping stone towards dynamic programming. So let's try a different so the problem with with this approach of starting from the beginning and going as far as we can and then backtracking is, let's do it one more time. So we do 3 goes to 3, we backtrack by 1, 1 goes to 0, backtrack by 2, 2 goes to 0, backtrack by 3, and now we're back to this 3. Is that we have this sort of loop, and to be able to handle this loop, it's like solvable. You could probably use some kind of hash table of sorts, but we can do a cleaner solution by, instead of, so all we want to know is, can we reach the end, not necessarily how, or we don't necessarily have to start from the beginning. Let's see what happens if we start from the end. Now just imagine, so 5 is the number we're trying to reach, and I'll use the same example here. Let's use this example first. Now let's say we started our iterator, instead of at the beginning, one spot away from the end. So we can say, can 1 reach 4? Well, yeah, if we did 1, we move it by 1, we would reach it. So now, instead of having to reach 4, we can say, we know we can reach this 4. Can we reach this j? Can we reach I now? Because we know I can reach j. Okay, can the rest of our numbers reach I? So let's move j back by 1 and I back by 1. And we do the same process. Can I reach j? Yes. We just move up by 1 and we would reach j. So now our goal is to just reach j once more. Can 3 reach one step ahead? Yes, it can, no problem. So we move j back 1, move I back 1. Can 2 reach this 3? Yeah, we can just move by 1 step and we're done. And then the proof to this problem is, does j equal 0? Because if we know we started at the beginning, so if in this repeating approach we saw that j is 0, then that means that we have a solution to the problem. So let's see what would happen if we did the same process with the second example. So we bring j to the very end, I is j minus 1. So can 0 reach 4? We can just skip this because 0 can't move at all. Can 1 reach 4? It can't. So let's try another one. Can 2 reach 4? It can't. Can 3 reach 4? It can't. So now we've finished iterating. And does j equal 0 at this point? No, j is equal to 4 because it didn't move at all. So that means that way we know that in a linear fashion we've discovered that you can't reach the final element in the array. So let's just implement that solution. So we have we can say like target. So target is our j, and that's going to be nums of length minus 1. And then we have our iterator, and we can just for let I equals nums of length minus 2, I is greater than 0, I plus plus. And if it helps, because we kept talking in terms of i's and j's, I can just make target index j. So we can say, so if you remember in this example, the second example, we see that this is 0, so we can just skip it and move back by 1. Let's reenact that by saying if nums I equals 0, continue. We don't want to deal with it anymore. So now we want to say, can I reach the final point? So how do you do that? So we say const can reach j, I guess, equals I plus nums I is greater or equals to j. So j is our target, and then I, for instance, in this example, I guess right here, so I is equal to 2, and nums I is equal to 1. So 2 plus 1 is 3. Is it greater or equal to 4? We will see that it's not. So we say if can reach j, then we can move up our j equals I, and then at the end we can just return j is equal to 0. So let's run our first example. Oh, I see. It's I minus minus. Okay, so there's that example. Let's try there's 2 examples. Yes, and there you have it. That's can jump game. And thank you, and catch you later.